Hello, in the previous video we stopped here we are supposed to apply boundary condition, and that we are using elimination method of handling boundary condition. There I was explaining this entire element has this entire bar has two element, element 1, element 2, where we have node 1, node 2, node 3, node 1, node 2, node 3. Node 1 is fixed, node 2 and node 3. Node 3 has some displacement 0.12. This is what we are seeing. We need to apply the boundary condition. So boundary condition is nothing but wherever there is a node, we need to eliminate corresponding rows and columns. Here in this problem, node 1 is fixed, but whereas node 3 has some displacement, we can't eliminate this. Here node 1 only it is fixed, but node 3, this is node 3, this node can move up to 0.12 mm, so we can't eliminate this. In here if you see our problem, we are here elimination approach. Here you can see in this as I explained, Ku is nothing but the stiffness is equal to force by displacement, where stiffness into displacement is equal to force. That's what we have written equilibrium equation. We need to substitute this data. This is nothing but a global stiffness matrix, global displacement vector, global load vector. Here if you see this, here I have written u1, u2, u3 is nothing but displacement, which is already given 0.12. Now using elimination method, here what we need to do, we need to eliminate first row, first column, because the first node is fixed. In this matrix, this is our 1, 2, 3, this is our first row and first column. If we eliminate this, the left out is we left out with 2 by 2 matrix, and these two data, right? So what we need to write, we need to write two equations, then we need to find two equations, two unknown. By using calculator also you can do, or manually you can calculate these things. How can we write? Since these two are eliminated, we left out with these data. First we'll write the equation 70 into 10 raised to 4 into u2. That's what I have written here. Next we have minus 75 into 10 raised to 4 into u3, because here you can see this is eliminated, this is eliminated, we have left it 2 by 2 matrix. First row, this column, this row, this column we need to multiply. That's what I have written here. 70 into 10 raised to 4, nothing but 70 into 10 raised to 4 into u2, first column, row into column. Next we have this one, minus 35 into 10 raised to 4 into u3. u3 is 0.12. That's what I have written, 35 into 10 raised to 4 into 0.12. Here we have minus sign, that's what I have kept minus sign here, which is equal to we have 60 into 10 raised to 3, which we have written here. Next second equation, this is eliminated, right? Second equation, minus 35 into 10 raised to 4, minus 35 into 10 raised to 4. Next into u2. Again next we have plus 35 into 10 raised to 4 into u3. That's what I have written, 35 into 10 raised to 4 into u3 is nothing but 0.12, which is equal to 0. I have written. If you simplify these two equations, simplification is very easy here. If we add two equations, here minus 35 into 10 raised to 4 into 0.2 and plus 35 into 10 raised to 4 into 0.12, these two get cancelled. If you see this, these two get cancelled. If these two get cancelled, next we left 70 minus 35. 70 minus 35 will get 35 into 10, 35 into 10 raised to 4 into u2 we are getting, which is equal to we have 60 into 10 raised to 3. If you simplify this, here you can see the simplification, we will get u2 is equal to 0.1714 mm. I hope it is clearly understood. This is how we can apply elimination method of boundary condition. Next we'll see the same problem with penalty approach. In penalty approach, if you see here, in penalty method, first thing in the penalty approach is we need to find out the c, which is constant, which is nothing but maximum of Cij into 10 raised to 4. What is this Cij? We will see now. See, if you look at our earlier matrix here, this is our global stiffness matrix. I hope you know this, how to form this. Here in the penalty approach method, we need to find the constant c. C is nothing but maximum of Cij. C is nothing but maximum of Cij into 10 raised to 4. This is what we need to find now. What is this? What is this? We will see now. What is this maximum of Cij? Maximum of Cij is nothing but the maximum value in this global stiffness matrix. What is that maximum value? That is nothing but our 70. 35 plus 35. 70 into 10 raised to 4 is our maximum value. That is nothing but maximum of Cij. Cij means Ij are nothing but row and column, that represent row and column. Here C22, if you return, it is also no problem, because it is second row second column. It is nothing but second row second column. Clear? Second row second column. So maximum of Cij is nothing but 35 plus 35, that is 70 into 10 raised to 4 is nothing but maximum of Cij. Again we need to multiply with 10 raised to 4. So if you do so, we are getting a value 70 into 10 raised to 4 into 10 raised to 4, which is equal to 70 into 10 raised to 8. This is the maximum value which we have found out. So once we found out this maximum value C, we need to add this stiffness, we need to add this value to the global stiffness matrix wherever nodes are fixed. We need to add this C in the global stiffness matrix wherever nodes are fixed. So if you see our problem, in the problem it is given node 1 and node 3 are fixed. Node 1 and node 3 are fixed. So what we need to do, we need to add this value, that C value. We need to add the C value here, we need to add C here, and we need to add C here. This is the fixed node, this is the fixed node. Means at first row first column we have fixed node, at the third row third column we have fixed node. So we need to add at the corners. So that's what I have written here. 35 is already there, we have added this 70, we have added this 70 into 10 raised to 4. Similarly here in the last, like wherever the nodes are fixed, we need to add this value. As we know that first node and third node is fixed, so first node we have added this value C, in the third node we added this value C. Addition we need to do here. Here it is 70 into 10 raised to 8, but we have added 70 into 10 raised to 4 because here 10 raised to 4 is already, we have taken it as a common for that, so we have added only 70 into 10 raised to 4. Once we do this, you need to simplify. Next if you add this, you will get 70,000, like 7 lakh 35 you will get. Similarly if you simplify this, you will get this. Once we get this, next step is to find out the global load vector. Somewhat it is different from elimination approach method. In penalty approach we use this formula to find out the global load vector. In global load vector we have like formula F1 plus C1, F2 plus CA2, F3 plus CA3. What are these things? Like here F1, F2, F3 are nothing but the forces which are acting at each node. This C into A1, C is nothing but maximum of Cij into 10 raised to 4, which we have found out just now. The same thing. What about this A1, A2, A3? A1, A2, A3 are nothing but the maximum allowable displacement from each node. These are nothing but allowable displacement from the each node. Allowable displacement from the each node, that is nothing but A1, A2, A3. If we see our figure, in this figure, here A1 is at node 1 where we don't have any displacement, so it is 0. We don't have any allowable displacement. At A2 we don't have any allowable displacement, but at A3 we have an allowable displacement of 0.12. So A1, A2, A3 is nothing but allowable displacement from each node. So here this is the formula. F1 is nothing but force at node 1, F2 force at node 2, F3 is force at node 3, C is nothing but maximum of Cij into 10 raised to 4, which we have found from these data. Like we need to substitute this data, then we will get this. So that's what we have calculated here. At node 1, at node 1, at this point we don't have any force, so F1 is 0, and we have maximum value 70 into 10 raised to 8, and we have A1 is 0, so A1 is 0, we have kept it as. Next we have F2 is 60 into 10 raised to 3, that's what you can see here, 60 into 10 raised to 3, plus we have this value. What is that value? C is nothing but maximum of 70 into 10 raised to 3, and we have A2 as 0. Next we have F3 is nothing but 0, F3 is 0. Next plus we have C into A3 is nothing but 0.12. So once you do this, next we need to simplify. If you simplify, you will get 0, 60 into 10 raised to 3, 840 into 10 raised to 6, because here it is 0 into anything is 0, so here you will get this entire term as 0, and you will left out with this term. If you simplify this, you will get 840 into 10 raised to 6. Once you found out the global load vector, next step is to form the equilibrium equation. Again we need to substitute the modified global stiffness matrix. These are nothing but modified element. Since we are using a penalty approach, we need to do these things. Once we do all these things, like we have substituted global stiffness matrix, global displacement vector, global load vector, so this is nothing but, once we do this, next step is to, here we can't do elimination here. What we need to do, we need to write 3 equation. Like we need to multiply this row into column, this row into column, this row into column. First what we need to do, this into this means 735 into 10 raised to 4 into U2. Next minus 35 into 10 raised to 4 into U2, 0 into means it comes 0, which is equal to 0. Similarly we have minus 35 into 10 raised to 4 into U1, 70 into 10 raised to 4 into U2, minus 35 into 10 raised to 4 into U3. Similarly we need to multiply 0 means we will get 0, minus 35 into 10 raised to 4 into U2, again 735 into 10 raised to 4 into U3, which is equal to 840 into 10 raised to 6. Those things I have written here. Those 3 equations I have written. You go through it. Once you return this equation, you use your calci where 3 equations, 3 unknowns. If you substitute these data, you will get this answer. U1 is equal to 7.285 into 10 raised to minus 6, U2 is equal to 0.1457, U3 is equal to 0.12. Since it is already given, it has to become the same answer. When you solve in the calci, you will get the same answer, 0.12. So once we calculate the displacement, next step is to determine the stresses. As we know that stress can be determined in each element by using this formula, E1 L1 minus 1 U1 U2, because first element is connected between node 1 and 2, so U1 U2. Here we need to substitute the value. E1 we know, L1 we know, minus 1 U1 just now we have found out, this is U1. Here you can see this is the U1. The same thing we have substituted here. u1 u2. If you simplify this, we will get 204 Newton per mm square. Again the same thing, we need to find the stress in the second element, e2 l2 minus 1 1 u2 u3, because second element is connected between node 2 and 3, so u2 u3. Again we need to substitute the values. 0.12 is given. If you simplify this equation, we will get minus 36 Newton per mm square as a stress in the second element. Once we do this, next step is to determine the reactions at the supports. The reactions is given by R is equal to K into U minus F. Wherever there is a fixed node, there we need to calculate the reactions. So reaction we need to calculate like this is the first row of the global stiffness matrix. This is the displacement vector minus we have F. Means if you see our equilibrium equation, you will understand here we need to find the reaction forces at the supports only, because reaction occurs at the supports. So what we need to do, we need to, since node 1 and node 3 is fixed, we need to find reaction at node 1 and node 3. Here these elements are for node 1 and these elements are for node 3. If you multiply this row with this column, which is equal to 0, and if you multiply these element with these displacement, which is equal to this, we will get the reaction forces. It is very easy. If you go through, you will understand. These are the first row elements of global stiffness matrix. These are the displacement minus first element of the global load vector. If you simplify, you will get this answer. Similarly, here I have written this is the third row of the global stiffness matrix. This is the displacement. This is nothing but a third element of the load vector. If you simplify, you will get the reaction force as just much. This is how we need to solve the penalty method. Thank you for watching. If you have any doubts, you comment below so that I can explain in one more video. Thank you. All the best.